Hi everyone, today we're going to talk about a new powerful algorithm design technique, namely the dynamic programming. Dynamic programming is an algorithm design technique which breaks down the complex problem into collection of simpler subproblems, solving each subproblem just once, and store their solution using memory-based structure. Let's take a Fibonacci sequence as example. As we remember, uh, the sequence start from two base case, which is the first term 1 and the second term also is 1, and we can keep calculating the later term by summing up first two terms. So 2 is the sum of 1 and 1. 3 is sum of 1 plus 2. 5 is sum of 2 and 3. And 8 is sum of 3 and 5. And as we remember, we use a simple recursive solution to solve this problem. We can express the recursive relation by defining each term. We defining two base case, the first term and the second term, and we calculate later term by summing up previous term, two previous terms. And this is the pseudocode for the simple recursive solution. And if we're trying to calculate the fourth term in the Fibonacci sequence, and we're going to recursively call Fib3 and Fib2, and Fib3 gonna call Fib2 and Fib1, and we just keep going until the tree reaches base case. And the problem of this approach is very obvious, that many terms are called many times. For instance, Fib0 is called 2 times, and the Fib1 is called 3 times, 1, 2, 3, and Fib2 is called 2 times, and here and here. And the question is the time complexity for this simple recursive solution is 2 to the power of n, which is exponential time, which is very bad. So the question is, can we do better than simple recursive solution? The answer is yes, by using dynamic programming approach. So let's see how we can solve this Fibonacci sequence by dynamic programming. And we just slightly modify this program. And previously, we're trying to solve this problem from top down. And now we're going to try if we can solve this problem by bottom up. So we know there are two base cases, Fibonacci 0 and 1. So we assign the array with base case. And we calculate the later term by using a loop. Let's say if I'm going to calculate Fibonacci sequence, the third terms, I just calculate previous two and return the value of the function. So in this way, it is easy to see the dynamic programming time complexity is linear time O n, which is good. And we compare with simple recursive time complexity, which is big O of 2 to the n, which is exponential, is less desirable. And we put this two different time complexity in perspective, and let's say we're going to calculate the 40th terms of Fibonacci sequence. The simple recursive solution would take 75 seconds. The dynamic programming only take 2 microseconds. And if we're trying to figure out the first 70 number in the sequence, that would take us 4 years to calculate it. Well, if we use dynamic programming, it only takes 3 microseconds, just a few microseconds. That's it for dynamic programming.